The entropy change that you need to heat at constant pressure of 1 bar, which is essentially 1 atmosphere, 1.1 bar, 1 atmosphere is 1.01 bar, for a substance from 0 to 298 Kelvin, so from absolute 0 Kelvin, to room temperature, that's called the standard entropy of that substance. So keep that definition in mind. Remember, every time you heat something, what happens to its entropy? It's going to increase, right? So this delta S would be S at 298K minus the S at 0 Kelvin, okay? And if we're doing it at a 1 bar pressure, that's standard pressure, so that superscript 0 there in the symbol stands for 1 bar pressure or 1 atmosphere pressure. That's your delta S, okay? That's called the standard entropy of your substance. Okay, so given that definition, can you answer this question for me? For which of the following processes is delta S equal to the standard entropy of nitrogen gas? That's the gas that in the air you breathe, it's 80% of the air you breathe, at room temperature, nitrogen's a gas, right? 298 Kelvin. So which of these 4 processes corresponds to the delta S that is equal to the standard entropy of nitrogen gas? You ready? It's the delta S if you go from 0 Kelvin to 298 Kelvin, right? So it can't be this. This starts at 0 degrees Celsius. This one's reversed from 298 to 0, right? So is it A or B? What do we know about when we get to absolute 0? What happens to gases? Eventually they turn into solids, right? So you start with nitrogen solid and change it to a gas. Okay, so the answer is A.